Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Salwa Nafisa. I'm from the Chemistry Education Study Program, Faculty of Teacher Training and Education, 11 Maret Surakarta University. In this video, I want to explain about acid and base, so enjoy for watching. Okay, for the next, do you know about acid? Yeah, acid is every substance that categorized as an acid tasted sour. Anyway, based on their origins, acids are grouped into two groups, namely organic acid and mineral acid. Organic acid come from natural sources, plants and animals, generally are weak acid. Example of organic acid are citric acid in citrus fruits, formic acid in ant and bee stings, and acetic acid in vinegar. Meanwhile, mineral acids are acidic compounds such as hydrochloric acid, stomach acid, found in the gastric system of humans and animals. Examples of mineral acid are hydrochloric acid, which is widely used in industry, sulfuric acid for carbohydrates, and hydrofluoric acid, which is usually used in glass factories. Okay, for the next, we will talk about characteristic of acid. There are several characteristics of acid. First, some types of acid are safe for consumption. If it is velvet to tongue, it will taste sour. Meanwhile, strong acid also taste sour but are not recommended for testing because they are damaging to skin tissue. And the second, if measured with special tools, the pH will be smaller than 7. And the third, if exposed to the skin, will feel sour for the acid is strong. And it can also damage woods and then corrosive or triggerous when exposed to the iron or metal, and then can conduct electricity because it contains electrolytes and so on. And then we will talk about base. Do you know about base? Yeah, every substance that is categorized as a base that is bitter and slippery. Okay, the next we will talk about characteristic of bases. Bases have characteristics that can be known through this human sense, such as first, bitter taste, and second, pure base is crystalline solid, and the third, bases have a pH greater than 7, and then slippery when held with finger it is caustic or damages skin tissue if the level is high, and then can be used to emulsify oil, and then can conduct electricity because it contains electrolytes, and so on. And the next we will talk about the theory of acid and base. Acid-base can be interpreted according to several expert views, such as first Arrhenius, and the second Bronsted-Lowry, and the third Lewis. Okay, for Arrhenius acid-base theory, an acid is a substance that will produce H plus ion when dissolved in water. For example, when hydrochloric acid is dissolved in water, it produces H plus and Cl minus ions. Then, another example, when sulfuric acid is dissolved in water, produce 2H plus and CO4 minus ions. Okay, according to Arrhenius, a base is a substance that will produce OH minus ion when dissolved in water. For example, when sodium hydroxide is dissolved in water, it produces Na plus and OH minus ions. And then another example, when calcium hydroxide is dissolved in water, produce Ca2 plus and 2OH minus ions. Okay, for the next we will talk about Bronsted-Lowry acid-base theory. According to Bronsted-Lowry theory, an acid is a species that donates a proton or H+. Meanwhile, a base is a species that accepts a proton or H+. And then the conjugate acid of a base is the special form when a proton is added to the base. And then the conjugate base of an acid is the special form when a proton is removed from the acid. Okay, for example, Bronsted-Lowry acid-base theory, hydrofluoric acid acts as an acid because it donates a proton to water, and then salt water acts as a base because it accepts proton from hydrofluoric acid. In addition, there is a conjugate acid-base pair, namely hydrofluoric acid acts as an base acid with F- as a basic conjugate, while water acts as a base with hydronium ions as an acid conjugate. And then for another example, acetic acid acts as acid because it donates its proton to ammonia. So ammonia acts as an acid base because it accepts a proton from acetic acid. In addition, they are conjugate acid-base pair, namely acetic acid act as an acid with CH3COO- ions as the conjugate base, while ammonia acts as a base with ammonium ions as the acid conjugate. Okay, we will move on from Bronsted-Lowry, and then we will talk about Lewis acid-base theory. An acid is a species that accepts an electron pair or is a lone pair acceptor. Meanwhile, a base is a species that donates an electron pair or a lone pair donor. Okay, for the next, I have an example from Lewis' theory of acid and base. Ammonia is a base because it provides a lone pair of electrons, while the H+ ion is a base because it accepts a lone pair of electrons from ammonia. After that, it produces ammonium ions. Okay, for the next, we will talk about the benefits of acid and base in daily life. Okay, do you know what is included acid in daily life? Example of acid in daily life are so many. Some of them are acetic acid found in vinegar solution, ascorbic acid found in orange, tomatoes, or vegetables, and then citric acid found in orange, and then sulfuric acid found in carbohydrates or fertilizer, and tartaric acid found in grapes, and then malic acid found in apples, formic acid found in bee stings, lactic acid found in cheese, benzoic acid found in food preservative, and so on. Okay, the next we will talk about bases in daily life. Do you know what is include bases in daily life? There are many examples of bases in daily life. Some of them are: first, sodium hydroxide or caustic soda or soda ash and potassium hydroxide as raw materials for household cleaning such as bath soap, laundry soap, detergent, bleach, and floor cleaner. The second, magnesium hydroxide and aluminum hydroxide contained in stomach pain medication or antacid, and then ammonia for disinfectant solvent or preventing infection, and as raw material for urea fertilizer. Okay, the next we will talk about acid-base indicator. Okay, the universal indicator for measuring acid-base is litmus paper. If red litmus paper is dipped in an acid, it will remain red. and if it dipped in a base, it will turn blue. While blue litmus paper, when dipped in an alkaline compound, will remain blue, and if it's dipped in an acid compound, it will turn red. Okay, acid-base indicators based on their origin are divided into two, namely natural indicators and artificial indicators. Natural indicators that can be used are turmeric, hibiscus flowers, red cabbage, roses, carrots, and so on. And the picture is example of natural indicators. Meanwhile, artificial indicators can be used are methyl red with a pH of about 4.2 until 6.3, and then methyl orange with a pH of about 2.9 until 4.0, and then bromothymol blue with a pH of about 6.0 until 7.6, and then phenolphthalein with a pH of around 8.3 until 10.0, and so on. Okay, I think it's enough for my presentation. I'm sorry about my pronunciation because I'm still learning to make an English language. And then if there are any suggestion and criticism, I will accept from you so that my next video will be better. And thank you very much. Don't forget to like, comment, and subscribe. Bye.